As we mentioned before, there are a few trailblazing activities in the future coming up. First and foremost, Mobile Core, which is a disaggregated and virtualized RAN and APC that provides mobile edge services, and we consider it to be a platform for the 5G deployments. And also we have multi-access core to provide connectivity services at the edge of the network, and a general platform for the edge cloud with multiple type of access technologies. So let's start with MCore. We are currently collaborating with the ORAN initiative to build an open disaggregated and virtualized RAN, both in the terms of design and implementation. So the Orion Alliance has a set of leading operators, and it will create a reference design comprised of architecture and components with open APIs, while in turn ONF should focus on an open implementation of the ORAN components and have an example platform that delivers ORAN with disaggregation and white boxes. So the operators and the rest of the ONF ecosystem should care about such components, will join the ONF and help ONF and ORAN succeed in this together. So the idea is that the ORAN is near the edge controller, and there's a need for an open source disaggregated decentralized unit stack, more close to the core network. And we also need open source distributed unit stack and white boxes of the distributed unit here in the 5G architecture. So what we have at the moment in ONF is that we have already an ONOS-based controller for XRAN for this component here. We can leverage the ONF momentum from its open source evolved packet core to engage the community to achieve this goal. And we are already in talks with one of our partners to open source a significant component of this stack here. So that is the current state, and that's why we put ourselves into the works with the ORAN initiatives, because we have already bits and pieces that can be used in a fully open source disaggregated solution. But we're also working toward the next generation of the packet core, which needs to be virtualized, because everybody can come in and give it, with an open source implementation, its own piece, and everybody could consume it. So the ONF ecosystem has been building through the MCore initiative such a core. It's not production ready, but it has main key features and key innovative capabilities that are going to make it, with some hardening and some bug fixes and some more implementation, more production ready towards 5G. So it has disaggregated and virtualized with network slicing. It could leverage Stratum and P4 runtime to map user plane functions into the hardware for performance scaling, and we have done that with the serving and packet gateway. And we have the opportunity to lead the industry in this space. So this is what we're doing towards the programmable core. So we are already publishing through the MCore initiative open source disaggregated and containerized EPC components that are available today in the ONF GitHub, open core GitHub. We have an ONOS-based core controller, which is currently available. We have an ONOS-based slicing controller with a set of applications to do per subscribe selection policies. And so this is coming together as a complete open source under the core umbrella solution. But we're also looking at moving the network from a 4G LTE EPC to a 5G NG core with this type of translation between what was before, so the MME and the serving and packet gateway, to more new components of the NG 5G, evolving basically from what was 4G to 5G with keeping the disaggregation and virtualization that we have shown here. So that was MCore. I know it was a very brief overview, but if you're more interested in that, I can put you in contact with our chief architect for MCore at ONF, and he can go in more detail about each of these components. So the other big initiative we're having as a trailblazing activity is the Open Edge Cloud. So the idea is that we have a converged wireline and wireless access plus some value-added services. We have disaggregated and virtualized network functions, such as the VLT, the BNG, and packet core functions. But we also add cloud services, such as aggregation, analytics, and content distribution. And a key component is the multi-tenancy, both with isolation and security, enabling a single operator to run multiple services, but also a telco operator to host services from cloud operators, and the opposite way around. So we're dynamically mapping service meshes across multiple clouds, enterprise, edge clouds, and public clouds. So that's the idea. You have multiple service meshes with different type of access, both residential and mobile, that span across multiple clouds. So you have your edge cloud, which is controlling the access, and a public central cloud, which offers maybe more services, and you have one mesh that connects them all for, let's say, one customer, and you can also have another mesh that, for another customer, connects them in a different way. As I said, multi-access support, both residential and mobile through MCORD, residential through SIBA, for example. And you can mix and match as much as you want. So you can go from the edge to the cloud, to the public cloud. You can go to from edge 1 and edge 2 to the public, or from edge to the central cloud. So that's the idea with this multi-access cord. And this is not running on any fancy things. It's always the disaggregated devices and the leaf spine topology we've been talking about now with Centralized, running Docker and Kubernetes to deploy the services, or also OpenStack for more heavyweight computing, deploying virtual network functions as microservices, and using XOS as a service mesh management and composition tool, both with wireline and radio access, converged core for both residential and mobile access, but also adding some services through using a CI/CD pipeline, so continuous integration, continuous development pipeline, managing these components. So this is, we call it trailblazing activity because it's forward thinking. And obviously we would like to have this deployed in the future, but we know at the moment there are still some details that need to be properly defined. So we are keeping it as a trailblazing activity, and we're looking at future contributions from the networking space. So just a recap, ONF is an operator-led consortium. You've seen the slide. And all the transformation that we talked about today, it's driven by these operators. And many more that are partners at ONF at many other different levels. I mean, you've heard Edward from KPN, and there are innovator operators here that give us a whole boost of ideas and thoughts for the networks of the future. So we talked about SIBA, that's for the broadband access. We talked about Trellis and the NFV fabric for the leaf spine topology in the data center. We talked about UPAN for the Unified Programmable Automated Network. We talked about ODTN. So these are the 4 reference designs that we're targeting and putting into deployment in the next few cycles, so in the next few quarters. Then, emerging reference designs and future activities, MCORD with the vRAN and 5G mobile, and CORD, multi-access CORD with access and edge cloud. All led by operators and put into production networks. So that is kind of what we have done and what we are looking at. So in the first, we've done exploratory innovation with the first generation of SDN controllers and first forward thinking. We have done the disruption with white boxes available, open source software available, merchant silicon, and it's proven with field trials and lab trials. Now what we're doing is that we're challenging the incumbent supply chain to be more and more fast in order to take the reference design into production and building an allied supply chain for support, integration, and putting what we output as reference design and open source software into service provider networks in production-ready quality. So for those who are used to here, please join us at EdgeCore booth for a SIBA demo, booth A1. And at the Stories booth, we're showing a Trellis plus UPenn demo with Stratum. So if you're interested in that, it's still going to be on now, and it's still going to be on tomorrow morning, especially with me at the booth. And come get me if you're interested in any of this. Or you could join us at the Telecom Infra Project in London for the 16th and 17th of October, and we can talk about more, for example, the TIP plus OOPT integration, ODTN plus TIP OOPT. Or the Programmable Forum, where we're going to show another SIBA demo with many more open OLTs and many more ONUs. Or you could come to California, which is very nice weather. In December, we're going to have an ONF event, which is driven by the ONF. It has different tracks about all the reference designs and the reference implementation we've been talking about. And you're going to see a demo per each reference design and reference implementation. So if you're interested, opennetworking.org/ONFconnect. So everything we said today, it's publicly available information on the ONF website, so opennetworking.org. And if you want to go more in depth, there are a couple of wikis, so wiki.openchord and guide.openchord. Wiki.openchord is mainly for Trellis. Guide.openchord is for like SIBA. Wiki.onosproject.org is for the Onos SDN controller. So you can start reading there. You can find a lot of information and more in-depth things from all the projects we discussed today. And if you want to pop me an email about anything, it's easy enough. It's Andrea@opennetworking.org. We're such a small organization. We're like 25 people, 27 people, 21 developers, which we have the luxury of the single name. So if you're interested about anything, you're interested in like very basic questions, very in-depth questions, drop me an email and I can put you in contact with the right people, or I can answer myself. So thanks for staying through the whole workshop. Any questions? No? Okay. So I guess enjoy a beer if you can. Thanks a lot.